Hello, it's Mr. Westhuizen with a more complicated circuit problem. This is more for grade 11 and 12, so let's go. I first need to look at the circuit. The 12-volt battery consisting of 3 cells. The current flows through a 5 ohm series circuit, and then it splits into a parallel circuit where you have a 4 ohm and a 12 volt, so there's a current divider, and then into series again. The first question is, what is the total resistance of the circuit? I'm going to do it the short way. This is the formula. R total equals R series plus R parallel, which is equal to the product of the two in parallel over the sum of the two resistors. Now remember, you can only use this formula for parallel resistance if there's only 2. If there's 3, you need to use the longer formula. That will then be equal to the 5 plus 4 times 12 over 4 plus 12, and if you then calculate that, you get 8 ohm. The next question is, what is the reading on ammeter A1? Now ammeter A1 is a series ammeter, so therefore we can try V equals IR. Always start with V equals IR, your Ohm's law formula. If it doesn't work, you look at other possibilities. We know that the total voltage, now remember we work with total current, therefore total voltage and total resistance. This is in the series circuit. So we will say total voltage 12 equals I total, and the resistance we just calculated is 8. So therefore I total equals 12 over 8 equals 1,5 ampere. 3.3. Now 3.3 says, what is the reading on V1? Now V1 is the voltmeter over the 5 ohm resistor. Therefore we're going to work with the 5 ohm as resistance, and we're going to say again V equals IR. Now V1 is I total because it's the total current flowing past, and it is the 5 ohm. Therefore the total current which we just calculated is 1,5, and the R is 5. That is equal to 7,5 volt. The next question, 3.4. What is the reading on V2? The reading on V2. Now, V2 equals IR. Will that work? That's always a question that you can ask. Now, do we have the current through the 4 ohm resistor? No, we don't. So we need to calculate the voltage by using another method, because V equals IR is not going to work. So therefore we must think of current or voltage dividers. Now the question is here to calculate V2, which is one of your parallel branches. Now if we have the voltage over the 5 ohm resistor, we can use the voltage divider principle, which says that 12 volt must split up between the voltage of the series resistor and the voltage over the parallel resistance. So we will say use voltage divider, just a note for you, and that will then be that V2 equals 12 minus 7,5 equals 4,5 volt. The next question, 3.5, what is the power through the 4 ohm resistor? The power through the 4 ohm resistor. Right, the 4 ohm is in my parallel branch, so therefore we can work with the one of the power formulas, which is P equal to V squared over R. P equal to V squared over R. Therefore, if we have the voltage over the parallel branch, we know that it is V2 is over the parallel branch, so it is 4,5 squared over the 4 ohm resistor, and that gives us 5,06 watt. Then 3.6, the question is now to, if switch S1 is opened, therefore S1 opened, will the total current increase, decrease, or stay the same? The total current, now if S1 is opened, the whole circuit changes into a series circuit. Current will only flow down here through the 12 ohm. So the total resistance will change. The total resistance will increase. Therefore, the current will decrease. 3.6 is therefore the total current will decrease. You need to first write the answer of the question that they actually asked. So it's decrease, and then they ask for a reason. The total resistance increases, therefore current decreases. Why is that? Because current is inversely proportional to resistance. And then I've added another question to calculate the current through the 4 ohm resistor. Now I want to use the ratio solution for this, the current through the 4 ohm resistor. So I'm going to say, well, it is the current through the 4 ohm equals the total current that splits up into a ratio of, now there's a 4 and a 12 branch, so 4 plus 12 is 16 parts, and the ratio that will go through the 4 ohm resistor is 12 parts out of the 16. If you look at this again, 12 parts of the 16 will go through the smaller resistor because the current, the biggest portion of the current flows through the smallest resistor. So it is 12 over 16, which is then 1,5 times 12 over 16 equals 1,125 ampere. That's all for this example.